how to set up a bot, a Twitter bot. So when you come to Amazon Web Services, one of the first things you want to do is sign in. Let me go to my management console. And there's a few main services that you want to work with. First, you want your storage, so that's S3, and you're able to pin these up here. So let's go ahead and pin S3. Let's start. Then you want Lambda. Let's start that, and then you have your step functions. Okay, and I'm going to tell you what all this does. Start that. What's next? Yeah. So we got those three main ones. You start with S3 because you have to load your code and storage. So let's go there. So you're going to write your code in Python or JavaScript or whatever you're using. In my case, my latest bot is math, right? You're going to pick a region, probably close to where you live for faster speeds. You're going to pick a region. You're going to create what's called a S3 bucket, which stores your stuff. So it looks like lately, my latest is zip. So what happens is if your code is too big, you can't type it directly into AWS. You have to save it as a zip file on your computer and then just load that. But you have this bucket, and then you copy, right? You copy where is it? Usually you copy the location of this file, this object in your bucket. Let's see here. What's the name of this thing? Where's my objects? Let's go to lambda zip. Let's see. So when you come here, you're gonna copy, not that. You're gonna do copy path, right? And your path is going to be, what is it up here? S3 slash mathbot slash lambda zip. So you don't actually see it, you just have to copy it. Let me see if it's over here. Properties. Let's just go back to mathbot. Bucket. You really can't see it from here. Okay. Okay, once you get your S3 bucket path copied, then you come into your Lambda, which is basically the Amazon tool that hosts your actual code configuration. It's not the file. It's not what stores your code files. That was the S3 we just left. But this is for the settings of your code. So you come here to function code. You paste the path from your S3 bucket with the zip file you just stored. You save that, and this is your main Lambda. Event bridge. This is how you set your triggers. So once you have your code in here, you want to tell AWS how often to run it. I turn these off because I'm using something else to do my timing, right? Which is the step function. But okay, once you have your code pasted in here, there's a few things you want to look at. Click back on your MathBot layer. You want to check your runtime. I'm using Python 3.7. Make sure you have enough memory allocated to what you're doing. Your handler is very important. This is the name of your file, mmlambdafunction.python or whatever it is, .py. This is the name of the function in your file. So it's def, lambda header, parentheses, event, comma, context or whatever. Event, parentheses, event, comma, context, close parentheses. Timeout. You don't really need 20 seconds usually. Maybe 1 second will do, but you need to give it some time to run. I'm reserving account concurrency. If you get an error here with something saying something about concurrency, you might want to increase that. I think I've seen that. Max age of event. I don't really save my events long, so 1 minute. Retry attempts. Sometimes I don't even do 2 retries. I only do 1. But I was having some errors, so I just decided to like boost up the allowance for errors. So that's pretty much it in here for like the important parts of your Lambda setup. Once this is set up, you could use your event bridge to like run it every 15 minutes, every 6 minutes, every 2 hours, hourly or rates, or every whatever. But for me, I have my code. My MathBot has quotes and posts and videos, and I wanted to run it randomly through that. I didn't want to run it in sequence. So that's where the step functions come in, right? So the step functions let you go step by step through a process, and that was how I was able to go through all my quotes and posts randomly without repeating, right? So it's let's see, it's still currently running. I'm surprised I got 2 that say they're running. That's odd to have 2 executions at the same time. Don't really know what that's about. That's a little weird, but let's see. Let's close this. All this stuff is kind of whatever. Okay, so let's open this. Is it running? Yeah, so this is still green. Let me go back to the other one which claims it's running. I don't really understand that. I got 2 running. When did that happen? That's super weird. Okay, you learn something new every day. What's crazy is I didn't notice that this thing was running. Huh. Okay, let me see something. One of these is only working. This is saying 30. Oh, this hasn't. Let's see. This hasn't run since maybe October. Let me see something. Oh, maybe. I know my posts go out like around like the 30. Oh my gosh, around the 38 mark. So that's how I'll know which one of these, I guess, seems to be active. 38. This is saying 49. October 31st. How could this be starting right now? I didn't start a new one. That's weird. Let me see something. This morning. Oh, you know what? I think I originally had this one's running on 49. I think I originally had a reset on this. So like it runs everything for like 40 days and then it turns on again. So that might be been what happened here is I had a timer to start a new trigger every 40 days. Okay, but anyway, let's go to this first one. So let me just show you how this thing is designed. So you have in here you have a step function. I guess we should start at the beginning of your steps function. The type of step function you have is a state machine. The name of your state machine I call my iterate count. And here, let me just go back to the particular execution I'm interested in. This is what actually runs your code loop. Okay, so here's the structure of it. You start with your original tweet file for Python. That was my main Lambda you saw, which is running off of the file stored from my S3 bucket. Then I remove one index. So I'll show you in a second when I go to edit this how that looks, or maybe it's over here, definition. Yeah. So you're basically creating this diagram using code, using JSON code. And you're saying, okay, first send a tweet from this particular resource, which is my main Lambda file. Then I got another Lambda file, like the main Lambda file stores all the code configuration, blah, 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 blah. The second one removes an index from this one. So I'm passing all the data from one Lambda instance to another and acting on it with the event. So inside of the Lambda handler, you can pass the event attributes or whatever. I don't know the technical code word for it. But all my info of the quotes inside of this bot, I can pass those quotes, the current state of those quotes, into this bot with the event. And I'll show you the code later maybe. And then I can act on that array of quotes and remove one, right? Remove what I just tweeted in this Lambda function up here. Then it says go to a choice. Depending on how many more quotes I have, I'll send another, I'll send a another tweet out, right? So it's going to send this quote, wait for a predetermined time, check, and now send a tweet if there's more quotes, or let me see tweets. If not, then it's gonna send it's gonna start over or something, right? So let's go to the details. If there's more, send the last tweet, basically. If there's no more, send the last tweet. If there's more quotes, go to the next one and figure out which number, right? Which number within my list of quotes that actual quote belonged to. Like, what order is it in? The identification number, basically the ID, right? The rank, the order. So then it's going to say, great, we have more tweets. Let's take the index, and then we're going to wait however long this is between tweets, 2 hours or something. Then it's going to say, okay, once we've done waiting, we're going to send out another tweet of the new array of quotes, the new list of quotes, and remove that past one, right? So we said we tweeted, we took note of where that tweet was located within the list. Now we're going to remove the one we just tweeted, and then we're going to send the next tweet, right? Randomly select another tweet without repetition because we already removed the one we sent. So let's look at it down here. Send a tweet, remove that tweet. If there are no more tweets in the list, like when we get down to one last, we'll send the last one and end it, and that's why I have the other trigger to restart this whole loop. If there are more tweets left, figure out the index of what the last one we just sent. Wait 2 hours and send another one, right? So send a tweet, remove that tweet, figure out the index of the tweet we first sent, wait 2 hours, send another tweet based on what's left over. Once you send that second tweet, then you repeat this loop until you run out, go here, and start this whole thing over again. So send another tweet, and then remove the index of that tweet, right? I'm sorry. Yeah, you remove the index. If there are more, figure out the index of your next tweet, wait, send it, remove the tweet you just sent, and repeat the cycle, okay? So that's how you basically set up your Lambda, your your Twitter bot at a glance. Of course, all the real code is in your Lambda files, right? So like your Lambda instances. So you got the main one that has the whole entire setup. You got to go to create a Twitter developer account, put all your code in. You can't even see the code from here because it's stored inside of zip files, right? The code for that bot is too big. Maybe I'll go in depth on that later if you guys want to see the actual code, right? But essentially what happens is then you go and you remove the very first tweet from that main Lambda file. So here's what that code looks like. I think it's small enough to fit in here. Yeah, it's actually instead of being in Python, it's in JavaScript. So I have exports handler. Event is what I'm passing, right? Event holds all the info from the previous Lambda instance. So I'm passing event attributes over to this one now. So tell me all those quotes you have, right? The index of this file is equal to the index of the event you're importing into here from the last Lambda. The list with all the quotes, all the pictures that go with the quotes, the size, the number of pictures in your list, the current tweet, the current image. We're gonna knock off the last tweet you sent, which is you're gonna take it off of the list of tweets and the list of pics. Gonna find the new size of your current list of tweets or pictures, and then we're gonna save the result of all this new info inside of a variable called result. And now the next event will pick up from here, right? So let's go back to the next Lambda function. So we removed, and then we're gonna note the index of the new, of what the new tweet's gonna be. So it's gonna get passed over the event from the last code after we remove the index Now we got to select what's the new index. So we're going to take the event from the last code. This is what the step function helps you do. It's got all of this, the resources, this up here, the resource codes. It's connecting all those resources together by those ARN, Amazon Resource Name Numbers or whatever. So passing the event, redefine this current event based on the list of codes from the last events, blah, blah, blah. When you copy over all the info and you do operations on it, like calculating your new index with random numbers, you can then save your results again. So now the name of the index is new index from this file as I identified it here, blah, 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 passing all your other info, tweets, pictures, and then this result is getting passed on into the event of the next Lambda file, right? So we removed the first tweet. We've created a new index. So we handled these two. Let's see. One of these, I think this is inactive. These are other things. I think what comes next, and I can double check from our step function. I think what comes next after you remove and you index is a wait, and then you tweet again. So let's look. Check the latest original execution. So you removed. The choice is not really a Lambda code. It's built into the logic of the step function definition here. And then you say, yeah, we note index, we wait. This is not a code, it's just a wait. Okay, new Pi tweet. This is you saying, this is you passing all the info along to generate the code for the next tweet you're gonna send after you knocked off and removed the last step function lambdas, because it's not too big. So where's my new Pi tweet code? Let me see, new Pi tweet. Let me check the definitions in here. New Pi tweet. They're trying to say it's an S3, but I don't think so. 665. Okay, it is 665. Apparently, this is a large file that won't allow you to do inline coding. I don't remember why I made this into. Basically, this means the logic, the code for this file is stored in an S3 bucket. So if we go back to the S3 bucket, I must have probably copied my original code and probably redefined a few like small things, probably cloned it and changed a few small things for it. But let's look. Oh, so that's what this Lambda 2 is. So I can't actually see it in here. I would have to actually show you guys my Visual Studio code. Ain't gonna go there today, but if you guys really want to see, just let me know, so you can see what the actual Lambda code looks like. My Python code for the big files. But those things basically hold all my quotes, and there you go. You have your step function to cycle through your leads randomly, instead of kind of going in order and being like predictable. I thought this was worth doing so that I could keep my content kind of fresh on the Twitter bot. Right now I can't remember exactly. I want to say that it's the actual new Pi tweet that, no, it can't be. Right now I can't remember how I have my main code set up to refresh, but I believe, let me go back, I believe I created a rule on my step function to refresh every 40 days. I did something in CloudWatch, I think. CloudWatch events, I think, helps you. It's kind of a roundabout thing, but I think I did something in CloudWatch to automatically reset my step function every, let's see, every, I want to say 40 days. Let me see if I can show this to you guys. So let's see if there's something I can edit. Interestingly, let's see if we can find CloudWatch. Interestingly, what's CloudWatch? You can't see it from the actual from within the actual step function dashboard. But I know I created a rule in here. So we're in CloudWatch. Let's look. Events, 39 days. Here we go. So if we look at this 39 days rule, what you'll probably see is that it's ARN. There we go. Iterate count. There we go. So my step function. Why you can't see this? Let's see the metrics for this, by the way. Why you can't see this from the step function itself, I don't know. It would be nice to be able to just see that. Have 39 days passed? No. So I'm really not sure, right? Because basically they're telling me, oh, actually it looks like they did 39 days from September 22nd. 30 days is October 22nd. Yeah. Okay. So there we go. That's why I have 2 executions running, because my original plan was I wasn't going to, I had enough content, I had enough quotes to last me 39 days, right? So basically, once I get through the whole quote machine, I start all over again randomly from the beginning. So that was my logic. That was my setup. It seems to be kind of working here, so I'm not really mad about it. I think what happened is I restarted my step functions a few times after the original, so that it was kind of premature. But for me, just to know it's working is good. It'll eventually, within the next time, it'll probably work itself out. And yeah, you can see here it starts September 22nd. So that's probably at some point. So I'm happy with it. No problems at all. And I think that's it. I think that's all you guys need to see to get you started, at least to know the general architecture of setting up a Twitter bot. Cool. If there's anything else, you guys can leave me a comment below, and I'll catch you next time. Good luck.